In this video, we're learning about magnetic forces. So we'll cover what magnets are, how to draw magnetic field lines, how magnets interact with each other, and finally, how magnetic strength affects force. Let's start with what magnets are. Now, magnets are basically any material or object that produces a magnetic field. They come in various shapes and sizes, but a common type is the bar magnet, which is shaped like a rectangular bar. All magnets have two ends called poles, a north pole and a south pole, and they are surrounded by a magnetic field. We use this term to describe the area around a magnet where its force can affect other magnetic materials. Magnetic forces are the pushes and pulls that magnets exert on other magnets. These forces work without the magnets actually touching each other, because they can act across empty space through the magnetic field. And the stronger the magnetic field, the stronger the magnetic forces will be. Next, let's look at how to draw magnetic field lines. You need to know that magnetic field lines are basically arrows we use to represent the direction and strength of a magnetic field, and that they always point from north to south. To draw magnetic field lines, we can start with a straight line going into the south pole and coming out of the north pole. Then a pair going into the south pole that are slightly curved, a similar pair coming out of the north pole, and lastly, some that loop all the way around. The final thing you want to do is double check all of your arrowheads on the lines are pointing the right way, because the arrows should go out of the north pole and into the south pole. Representing our magnetic field with lines like this shows us where the field is, which direction it's acting in, and the relative strength of the field in different places, because the more dense the field lines are, which is to say the closer together the lines are, the stronger the magnetic field is. For example, the field would be much stronger over here, by the north pole, than it would be out here to the side, where it'd be weaker because the one by the pole has lots more lines going through it. Now, in real life, we can't see the field lines and magnets aren't always labeled with the north and south. However, we can easily find the poles and field lines by using a compass. This is because the needle of the compass is actually a tiny bar magnet, so it always lines up with the field lines of the magnetic field it's put in, and always points to the south pole of another magnet. So if we put our compass over here near our magnet, we could draw an arrow in the same direction as the compass needle, and as it's heading towards this pole, this must be the south pole. If we place the compass over here though, the needle would be pointing away from the magnet, so this must be the north pole. By doing this over and over again in different places, and then joining up the arrows, we eventually recreate the same pattern as our field line diagram from before. Next, let's explore how magnets interact with each other. First, when you push two north poles together, they repel each other, which makes it really hard to squeeze them together. And if you try to push two south poles together, the same thing happens. We can see why if we draw the field lines between them. It's because the field lines from each north pole push against each other, creating a force that drives the magnets apart. When you push a north pole and a south pole together though, they attract each other. This happens because the field lines from the north pole of one magnet flow directly to the south pole of the other, and the interaction of these magnetic fields creates a force that pulls the magnets together. Magnetic forces get weaker as magnets get further apart. If you hold two magnets close together, there's a strong force, but if you move them just a few centimeters apart, that force becomes much weaker. This happens because magnetic fields spread out as they get further from their source, so they become weaker with distance. Finally, let's look at how magnetic strength affects force. Not all magnets are equally strong. Some magnets, like the small ones in your refrigerator, create weak magnetic forces, while powerful magnets create much stronger forces. So when we talk about the magnitude of magnetic strength, we are referring to how powerful a magnet's magnetic field is. The strength of the magnetic force depends on the specific magnets involved though, because their magnetic fields interact with each other. For example, two strong magnets will have a much greater force between them than two weak magnets, while a strong magnet near a weak one creates a force somewhere in between.
If you haven't heard yet, you can find all of our videos on our website, cognito.org. You'll also find questions, flashcards, exam-style questions, and past papers. And we track all of your progress so that you always know what to study next. So sign up for free by clicking here, or browse our playlist here on YouTube.